In this video, we present a short demo showing our project BrainWheel, a brain-controlled electric smart wheelchair. BrainWheel has two modes, a manual mode and an autonomous one. We will be showing both in this demo. BrainWheel also possesses some features to maintain users' safety. One of those features is the obstacle detection and avoidance, as the chair stops when there is an obstacle in front of it. Another feature is that in case of any system faults, an emergency message will be sent to the user's caretaker. This is a short video explaining the main idea of the project.
In our first demo, we show the manual mode of the wheelchair. In this mode, a screen has 4 flashing boxes as shown here. When the user looks at one of the 4 flashing boxes, the system registers the command corresponding to the box that the user is looking at, and the wheelchair can execute the requested instruction. You can see the user looking at the required instruction in the screen view on the right. You can also see the instructions written below for clarity. As you can see, the wheelchair executes the forward instruction correctly. The user now wants to move to the right, which is also executed correctly. We will now speed up the video, as the wheelchair will always predict the instruction correct. Our tests show that our system can predict the correct instruction with 99% accuracy.
Obstacle detection is one of our wheelchair security features. In this demo, we are going to show how obstacle detection works with the manual mode. At the beginning, the user is given the system forward commands continuously. The first one has been done successfully. The second forward command begins, but it's interrupted by the obstacle detection system due to detecting a wall in front of the wheelchair. The user still gives the forward commands, but the wheelchair never listens. The wheelchair does not execute any instruction that will cause the user to hit an obstacle. However, the wheelchair doesn't have to wait for the object to move away to continue listening to instructions. When the user changes his command to a right command, the wheelchair can execute it because it will not cause a collision.
This demo will show the autonomous mode of our project. The user first selects one of the predefined locations on the screen using the PCI GUI. The motion planning module then uses the GPS submodule to find the wheelchair's current location and then uses the GSM submodule to send a request to an online GPS navigation API that can return the high-level mission plan. The mission plan is the path that should be followed to move from the wheelchair's current location, which is the faculty gate in the demo, to the user-specified target location, which is one of the buildings in our faculty. The motion planning module then uses the occupancy grid from the computer vision module to plan the route that should be taken and sends instructions to the embedded systems module to move the wheelchair until the target location is reached.
In this project, we presented BrainWheel, a BCI-controlled electric smart wheelchair with autonomous capabilities designed to be easy to use for people with disabilities. As shown in the demo video, BrainWheel supports two modes of operation: the manual mode, where the user controls their movement by looking at a particular button on a screen, and an autonomous mode, where they can select one of certain predefined locations, and the wheelchair moves there autonomously. We were able to implement the manual mode with great results. It takes 5 seconds to predict a new instruction, and 3 seconds to run the instruction on the wheelchair. All other modules also work well inside this time frame, and we were able to implement a working proof of concept for the autonomous mode. At any given time, if any issue occurs with the wheelchair, an emergency event is triggered, and an SMS is sent to the designated caretaker. We hope we can continue improving this project so it can one day be a product and have a positive impact on people's lives, especially those with disabilities that prevent them from living a normal everyday life. Thank you.